Okay, so I'm going to talk about the distributive property here. In particular, what we're going to be doing is we're going to be doing a monomial times a binomial first, but I'm going to show it by examples. So let's say we had 5 times 3 plus 7. Now what we could do is technically, if we were going to follow BEDMAS, is we could say that 3 plus 7 is 10. So this would become 5 times 10, and 5 times 10 is 50. But we're going to do it in a different way. What we're going to do instead is when you have a number and it's right next to a bracket, in math, when there's no space, the assumption is that it is a multiplication. So the 5 right next to the bracket with no plus and minus after it, so it's kind of a blank over here. This means that it's 5 multiplied by the bracket. And what we could do is you can multiply it once per term. That's a term, open plus, that's a term. So it's 5 times 3, 5 times 7. So that's going to give us 5 times 3 is 15, and we get rid of the bracket at the same time. So 5 times 3 is 15, 5 times 7 is 35, and 15 plus 35 is 50. So example 2. Let's say we had 5 times 3x plus 2. So the 5 is right next to the bracket, so we could multiply it. So we're going to get 5 times 3. And the way we multiply it is we go 5 times 3 is 15. So 15x, 5 times 2 is 10. And that's that. By the way, the mathy word we're going to eventually use for that is, we call this expanding. Going from there to there. So this is called expanding. That will matter more near the end of the course, which normally which would be a bit from now. Okay. Example 3. 8 times 3x minus 5. So what we have is, again, it's a multiplication, so that's going to multiply by, there's 2 terms in the bracket, we multiply the thing in front by each of those 2 terms. 8 times 3 is going to give us 24x. 8 times 5 is 40, between the calculator, but it's actually 8 times negative 5. So that's going to give us negative 40. Example 4. So I'm going to adjust this slightly over to give myself more room. There we go. Example 4. So if we have minus 3, 2x minus 6. Notice the negative is not next to the bracket, so it's still going to be a multiplication. And there's kind of 2 ways to go about this. So one way to do this, so we'll say kind of like a method 1. I'm going to rewrite it just so I can highlight. One way to do it is to take the entire minus 3 and say this is the thing that's in front, and then multiply that negative by each of the 2 numbers in the bracket. So negative 3 times 2x is negative 6x. Negative 3 times negative 6 is plus 18. Now there's also kind of a method 2 way of doing it. And you could do either way is going to work. You're not stuck one way or the other. So minus 3 times 2x minus 6. So what we could do instead is we could multiply just the 3 in. Now the difference with this one is that since the negative is also multiplied by the bracket, we actually can't get rid of the brackets yet. So what's going to happen is we're still going to have the negative. 3 times the 2 is 6x, and the 3 times the negative 6 would be negative 18. Now when there's a negative in front of the bracket, it goes back to the previous lesson. When we get rid of the bracket, we change the sign of everything in the bracket. And so there's a minus in front of the bracket, so that becomes minus 6x. and the minus 18 becomes plus 18. And either way, you end up with the same answer. So you could choose method 1 or method 2. They both work. Whichever one makes more sense to you. Okay, let's say it's not a number in front. Let's say it's a variable in front. So we have x times x plus 7. So what happened in this case is the x times the x, so it multiplies again as usual. Foop, foop. X times x is x squared, and x times 7 is 7x. Nothing much else to say about that one. It doesn't have to be x's, of course. It could also be w's. So w times 5w minus 3. So what we have here, we multiply into the bracket, and we get, so w times 5w, we mostly just multiply the variable. So that's going to be, it's kind of like a 1w times a 5w. 1 times 5 is 5, and w times w is w squared. And then the w times the minus 3 is minus 3w. Example 7. Let's have a number and a letter in front. Or in math speak, a scalar and a variable. That's the scalar and that's the variable. You don't have to know that. You do not have to know that. But so it's better to know. So what we're going to do is we're going to multiply it in. 7. So we do, first we multiply the numbers. 7 times 2 is 14. W times w is w squared. Then with this one, 7 times 1 is 7 plus 7. That's the plus. And then the w is just w. So that'd be 14 squared plus 7w. Example 8. We will use a, because why not? Okay, what's different here? What's different here is I put the monomial, so I put the thing that only had one term to the right of the thing that did not. So what happens here is that we don't actually have to multiply forward in this direction. We could always actually technically multiply the second bracket by the first. So what would happen there is we'd go 6 times, so it comes out to be the same thing. 6 times 5a is 30a, and 6 times negative 2 is negative 12. Example 9. 4 times x squared minus 3x plus 11. So now we have a monomial times a trinomial. There's 3 terms in there. There's that term, and that term. And what we're going to do is we're going to multiply it by this, and by this, and by this. So we get 4 times x squared is 4x squared. 4 times negative 3 is negative 12, and we still have the x. And 4 times the 11 is plus 44. Example 10. So minus 3x times 2x squared plus 4x minus 7. Okay, now we're getting into some fun stuff, right? So we're going to have here, it's going to go into that, and that, and that. So minus 3 times 2 is minus 6. X times x squared, so we have 1x here and 2x is there. When you have exponents like that, you add them. So we get minus 6x cubed. Minus 3 times 4 is minus 12, and x times x is x squared. Minus 3 times minus 7, a negative times a negative is a positive. And you can use your calculator, of course, for all of this. Positive 21x. And when you expand that, that's the solution to it. So I think what I'm going to do is I'm going to save the last couple of examples for the next video.